This is the tutorial for Chapter 7, Section 5, titled Rational Exponents and Radicals. And so we're going to take a look at some radicals that are not just square roots, but some cubic roots as well. So this is called a cubic root here. This index tells us that we're looking for three roots of 64. So three numbers that multiply to make 64 that are all the same. And that would end up being 4. And so you see, if I multiply 4 times 4 times 4, two 4's multiply to make 16. 16 times 4 makes 64. So the cubic root of 64 is 4. Here we're looking for another cubic root, but of 625. So since this is an odd number, you're going to try odd numbers. Just as if it's an even number, try even numbers. And so the cubic root of 125 is going to end up being 5. And you can see it, you can check. Multiplying two 5's make 25. 5 times 25 makes 125. And so that is the answer. This is the fifth root. So 5 numbers now. 5 numbers that multiply to equal 32. So you know the number's even, so you got to try even numbers. And when you start multiplying numbers, you see how they get pretty big pretty quick. So you see how 3 4's made 64, and 32 is smaller than 64. So I'm going to try a number even smaller than that. And the answer ends up being 2. You see 2 times 2 times 2 times 2 times 2. If I multiplied out all these 2's, I'd end up with 32. You see 3 2's make 8, 2 2's make 4. 8 times 4 is 32. Well, this is the square root, so no index here just means that we have a square root. And two numbers that multiply to make 100 are 10 and 10. So fourth root of 1, well, 1 times 1 times 1 times 1 makes 1. So that would just end up being 1 in this case. And 225 is 15. So again, the rule is odd numbers try odd numbers, evens try evens. Let's take a look at some other examples. Here we have to write each expression in radical form. And so what we've got is a numerator, which represents the exponent. And the whole thing's an exponent, but this is the whole number exponent that we're going to end up using. The 2 down here represents the root, the number of roots. And so I'm looking for 2 roots, and then of b, but then I'm raising that to the 3rd power. So this is one way to write it. Or I could also write it this way. I could write the square root of b to the 3rd power and just cube b and then take the square root. But I find this easier, so that way the number doesn't get as big, because once you start cubing numbers or multiplying numbers, the numbers get really big really fast. It becomes a little bit more difficult. So this is the way I would end up doing the problem. I'd take the square root first and then cube that answer. So again, another way to write that would just be, since it's a square root, you could just write b, the square root of b, all to that 3rd power. Here we have to take both numbers to the 2nd power, or to the 2nd root, because that's what this is saying when it's outside the parentheses. So I'm going to take 36 and x, take the square root of both of those numbers. Again, it's being raised to the 1st power because that's what we have right here. That's the power that goes outside. So the square root of 36 is 6, but you can't take the square root of x. So you have to leave it underneath the radical sign. So on this one, 25 is not inside parentheses, so we just have to bring down the 25 and then take the square root of y, and that would be the radical form. Since I can't take the square root of y, we just leave it like that. Here we have 81, s to the 2/3 power. So 81 is not to the 2/3 power. 81 is actually to the 1st power. So we're going to bring that down and then take the cubic root of s and then square that answer. And so I'm going to go ahead and take that cubic root and square it. So I'd write it and end up writing it like this. You can also write this as 81 and then times by the cubic root of s squared. This is another way. So I would take either of these answers here. And on this next one, it's a little bit different. See, 72 is not a perfect square. B is not either, but there is a perfect square in 72. So that's what you want to think of. Think of perfect squares. Think of like 36. 6 times 6 is 36. And 36 goes into 72 2 times. So this is the same thing. Now I could go ahead and take the square root of the individual factor here, and I'm left with 6 square roots of 2b. So on the next one, I have a cubic root. And so I'm looking for the cubic root of 125a, and then I'm going to end up squaring this answer. And so when I do that, I end up having here the cubic root of 125 is 5, and then I've got to square that, and then I've got a squared underneath the fraction, or underneath the radical sign, because I can't take the square root of that. I don't have 3 numbers that multiply to make that a squared, only 2 numbers here, and so I've got to leave that as the cubic root. So I have that cubic root sign there. I'm going to fix that and make it look a little clearer. So the cubic root of that a squared. So I can go ahead and multiply out the 5 squared, so it's 25, and then cubic roots of a squared is the answer on this one. So on the next one, let's check out the next problem here. Next problem, we end up seeing some numbers in radical form that we have to put in exponential form. So we're going to kind of work backwards. Remember how I talked about how the denominator represented the number of roots. So this represents our denominator, and then the number underneath that's being the exponent here represents our numerator. And so I would rewrite this as b to the 4/3 power, and that would be the answer. So over on this one we have a square root, so I could rewrite this as 3x to the, and then 4/2 power. Well, you see how 4 halves, well, that just ends up being the same thing as 3x squared. So that would be in exponential form. Now, if we wanted to simplify this, then this would be the same thing as 9x squared. You have to multiply both numbers out. But writing it in exponential form, you could write it this way. But I go ahead and simplify it in this case, so I'll write it as 9x squared. So on the next one, we've got a cubic root of 125. So I can take the cubic root of the 125, and I know that's going to end up being 5 because I've seen that before. Now the cubic root of d to the 4th, you see, you want to break it down to perfect cubes, and we do have a perfect cube in d to the 4th. We have d to the 3rd. See, d to the 3rd times d to the 1st makes d to the 4th. And I've got a perfect cube here, and so I can take that cubic root, and it leaves me just with d, because the 3 numbers that multiply to make d to the 3rd would just be d times d times d. So d would be the number that I pull out once I take that cubic root, but I cannot take the cubic root of d to the 1st, so I have to just leave that underneath the radical sign. So I go ahead and pull all this stuff together, and I'd write 5d times by the cubic root of d. Taking a look at another example here, we've got 49, which is a perfect square, makes 7, but a is not a perfect square, so we have to leave that underneath the radical sign. Here we have 3 numbers that make 64, and then we have to square this answer as well. So let's go ahead, and what I like to do is I like to take the cubic root first, if at all possible, and that's what I'm going to do here. So I'm going to take the cubic root of 64, and then I'm going to square that answer. You can always do that, and I think that becomes easier rather than trying to square 64 and then take the cubic root. And I can do the same thing on the next one. However, this is not a perfect cube, so nothing's going to happen on that part. So I take the cubic root, which is 4, and then I square that answer, and that makes 16. And then over here, I can just write this as the cubic root of b squared. So I was not able to take the cubic root of b, so I just left it underneath the radical sign, went ahead and squared the number, and just leave it in that form there. So on this last one of this type, 4 numbers that make 256, and so that's going to end up being 4 times 4 times 4 times 4. So 4 is going to be the 4th root of 256, and then I have to take the 4th root of b to the 5th, and so that's going to be, I break this down again, b to the 4th times by b to the 1st. And so you just break it down so you can see how many b to the 4ths you have, and I just have one of them, so I can pull that one out. So my answer is going to be 4b, b because b to the 4th root is just b, because b is the number that multiplies to make b to the 4th. We're going to multiply 4 of them together, times by the 4th root of b. So that would be the answer there. Let's take a look at the last problem. This is a word problem that good calculator problem here. So it talks about to estimate the age of an organism. Archaeologists Measure the amount of carbon-14 left in its remains. Approximate amount of carbon-14 remaining after 5,000 years can be found by using this formula. And so where A0 is the initial amount of carbon-14 in the sample that is tested. It says how much carbon-14 is left in the sample after 5,000 years, and the original amount contained was this amount. Okay, so this right here represents A0. It's the initial amount is right there, A0. So I know that I'm going to put 5 times by 10 to the negative third power, and then times by 2.7 to the negative 3/5 power. Now, we can go ahead and use a calculator on this one. There's no 5 roots that multiply to make 2.7. There are 3 numbers that multiply to make 2.7, but not 5. So we're going to go ahead and I'm going to use a calculator on this, and the way I'm going to do that is I use a button that either a lot of the newer calculators have a button that looks like this. It's a fraction button, and this makes it a whole lot easier. Otherwise, you'd end up having to use the radical button, and a lot of the calculators now will have this button as well. So you can use a button that looks like this in conjunction with a button that looks like this. And so those two would give you this value right here. You could break this into that radical form, find the 5th root of 2.7, and then raise that to the negative third power. And so if you enter this number, usually it tells you it's an order in which you have to do it, because you have 2 things to enter. You have the root to enter, then the radicand to enter, and then once you press that button, it'll give you that answer, and then you press this button and enter the exponent, and then it'll give you this entire answer. And then all you have to do is multiply by that 5 times by 10 to the negative third. And everything's being multiplied, so you can do it all in conjunction. You can go ahead and enter times by 10 and then press this exponent button again to the negative third times by 5. Now, the calculator I ended up using had a function in which it had this fraction button. So all I did is I entered 5 times by 10 to the negative third, and I went ahead and put that in parentheses. And so my calculator had some parentheses that I was able to enter, and it wasn't necessary because everything's being multiplied, but sometimes I just like to do it just to ensure that things are done correctly. And then I entered 2.7, and I put that in parentheses, and then I entered a button that looks like this exponent button, and that gave me a little icon here, a little area to enter a number of an exponent. But I didn't want to enter a or an integer, I wanted to enter a fraction. So I pressed this button, and that allowed me to enter negative 3/5. And once you go ahead and do that work, let's see here, you end up getting 2.8. Let's check that real quick. 2.755 times 10 to the negative third, and then they just rounded it. So write your answer in scientific notation, they said, but they went ahead and rounded it to 2.8 times 10 to the negative third. And these were in grams. That was the amount left after that 5,000 years. So those are the types of problems that you'll see on tonight's homework. Good luck.